Hi everyone, so today we're going to look at how to transfer information or make available information that is in an assembler function and make it available inside of some other programming solution that you've written in C. Alright, so I've already transferred the programming solution into MPLAB X. I have two files. I have a C file that contains my main function, and I have an assembler file that contains my assembler routines. Okay, they are two separate things, and the C file right here has an include to my board support or chip support package through xc.h. It has the configuration registers right here, which could be modified and sort of redone using the configuration bits window. That's for the PIC32. Okay. But you also have things that are similar like to that for like the PIC16, for instance. Okay, here's my my prototype for a function that is written in assembler in a different file. I've declared it as extern so that my C compiler knows that it's defined in a different location. All right, it has an input variable or sort of an input parameter right there, and it's defined as having no outputs. All right. Next up, I'm going to set up a global variable, and I've sort of flagged it as being global by writing the word global, just to make sure it's really obvious, because rightly so, a lot of people will tell you that writing global variables in your programs is a terrible idea. And you know what? Generally, it really is. If you use them sparingly, and you're very, very careful with them, and use them in very specific situations, it's a compromise that might be okay. All right, and this is, I think, one of those effective compromises. I've said it's unsigned, it's an integer, and that it's volatile, so I don't want it optimized away. All right, so the rest of this is a standard main function right here. I should have made that void main or int main and void, but anyway, this will work too. I've set up my port B to have digital output. I have a call to my assembler function. So this is similar to the other two videos. It's actually exactly the same as the other two videos. And so I'm going to call this function that I've defined in my assembler file. Okay, this other file. Inside of here, I have my latch register for port B that's going to be set to 0, then set to some value. And this, if I had LEDs connected up to my my board, my chip, they would turn on and or off first, then on, off, then on. Here, the on setting is being defined by whatever is inside of my global variable. So every time that line in 47 gets called, it will go looking at the global variable value and insert it as a bit pattern into the register latch B, and that will turn particular LEDs on or off. That's effectively the goal here. All right, let's take a look at the assembler function or the assembler file. The comments are written in C style. I have again a call to the board support or chip support header files through xc.h. I've defined that it is what follows goes into flash memory. I've said to the assembler, if you're going to optimize anything, don't optimize anything. Here, I then say right in here, these three important lines right here. What I'm saying is that there is a function. This is how we set up a function in assembler. And the function is called ASM function. It doesn't say anything about input parameters or output parameters. It doesn't say any of that. But what it is saying is that this is a function right here. After that, and I've explained this in the other videos, there's some business about taking stuff and putting it on the stack and moving the stack pointer. After that, some business about the latches and setting things with respect to the latches themselves. Then there's some math operations here that were just part of an exercise. Now, this last bit right here, there was a division operation that occurred at the very end, and the quotient for that division was stored in a register called T3. For whatever reason, it doesn't really matter why. I want to take the quotient, the basic answer out of my division, and I want to send it back and use that to set the bit pattern on the LEDs that I want to turn on and off. Okay. In order to do that, what I do is I load an address. What address? It's the address for my global variable. That's been set by the compiler somewhere in memory. I don't know what it is. And so I'm going to ask the compiler to tell me. So it will go looking for this symbol somewhere in the compiled code. And it'll say, oh, I found the address. The address is such and such. And I want it to be loaded, that particular value, I want it loaded in register S0. Okay, so I want it stored in S0, and then I want to have that address available to be able to pull the value out of T3. So T3 is a temporary register that holds the quotient from my division. I want to take that value and I want to send it to the address stored in register S0 with 0 offset. That's what 0 parenthesis S0 means. Okay, so it's going to, so 2 steps. 1, what is the address of my global variable? And then 2, can I take my contents of my temporary register, the quotient that comes out of the division, and send it into the address for my global variable. From there, I will forget about my global variable. I'll move on with the rest of the things that need to happen in my assembler routine, and then I will go and retrieve it. Okay, so let's go and compile this. On the screen, you can see that I've got my latch register displayed right here, and I have my global variable set up as a watch right there. In order to set up watches on variables, you do new watch, and it will store it. It will make it available inside of my watch window right there. I'm going to close that. I'm going to make that smaller so we can see more of the screen. There we go. All right. So I'm simulating on the PIC32 simulation model what's going on. I have landed at the breakpoint that happened right after the division. And now I'm going to see if S0 will take S0 will end up taking, where is S0? There we go. There's S0 right there. If it will take the address A0000200, like that, let's step. S0, there we go, right there. So you can see that it changed. It has now got the address of my global variable, because you can see the global variable has this address that was set before I arrived inside of the assembler routine. Let's see if I can move this out of the way. Nope. Let's try that. No, it's not letting me. Okay, I'm running a screen real estate here. All right, we're going to remove the variable right there. Otherwise, we can't see anything. There. There. Okay. So where am I? I am right there. So now I need to store the contents of, I shouldn't have erased that. All right, so I have now at this point stored the contents of T3. Where is T3? Let's go take a look at T3. Target memory views, CPU registers, T3. Right there. It has the value of 4. Where was 4 from? 4. Oh, there was T3. I needed to show you the, come on, variables. Global variable right there has a content of 4. Okay, that was the quotient. Next. Let's move along. We're going to skip. We're going to return back to our calling function, which was main. I'm now past this. I've exited my assembler function. I'm now in my while loop. My latch will turn to 0. There There, it's turned to 0. You can see right there. Now it should take the value of 4, which was the contents of my global variable. And there you go. You can see it's been turned to 4. And then my LEDs would light up in a particular pattern to represent, let's see, this would be 1, 0, 0. So one of the 3 LEDs or one of the 4 LEDs would be turned on and the others would be turned off. And there you have it. Passing information out of, or taking information out of an assembler function, putting it into a global variable to make it available for usage by another function without passing back in the normal way that functions pass back.